Let's say that we flip two coins. Suppose that we want to analyze some of the outcomes and events when we conduct this trial. This is an example of a compound trial, and in this lesson we're going to see how to analyze situations like this. What do we mean by a compound trial? A compound trial is a trial that's comprised of two or more simpler trials. So we've drawn a schematic diagram to indicate this situation here. So in this example, we have the compound trial consisting of flipping two coins. And the two simpler trials that make it up are to flip one coin and then to flip another coin. Now let's say that we want to analyze the sample space and to work out some probabilities of events or outcomes for the compound trial. Well, the simpler trials are easier to deal with. We can write down the sample spaces there. So in this example, the sample spaces are just heads and tails in both cases, which we've shortened to H and T. Now, to get the sample space of the compound trial, we can use a two-way table to combine the sample spaces of the individual trials. So here's the two-way table. So along the top we have the sample space from the first trial, and along the left column we have the sample space from the second trial. And then we fill in the entries of the two-way table, and these entries give us the outcomes of the compound trial. So the sample space of the compound trial consists of the four entries here in this table. Okay, so that's not so hard to see in this simple case where we just have a relatively small number of outcomes in each case. But in more complicated compound trials, this is a useful idea. You can understand the sample space of the compound trial by constructing a two-way table using the sample spaces of the individual trials. Alright, what about calculating the probabilities of the outcomes? How do we calculate the probabilities of the compound outcomes? In this example, the two trials do not affect each other. Flipping one coin will have no effect on what happens when we flip another coin. So we say that the trials are independent. And in the case where the two trials are independent, we have the following fundamental fact about compound outcomes. The probability of the compound outcome is the probability of the outcome of trial 1 times the probability of the outcome of trial 2. This is a very important fact, and it only works if the trials are independent. Okay, let's apply this fact in the example above. That is the example of flipping two coins. So let's say that we wanted to calculate the probability that both coin flips result in a head. So we're looking for the probability of head, head. According to our rule, that's the probability of a head in the first trial times the probability of a head in the second trial. And now we know that the probability of a head when we flip one coin, as long as the coin is fair, is a half. So we see that the probability of getting heads in both trials is 1/4. And we could work out the probability of all the other three outcomes of this compound trial. And we'll find in each case that the probability of the outcome is 1/4. You should check this yourself. Now, we could, for example, use this information to analyze slightly more complicated events. For example, we might ask, what's the probability of getting exactly one head from the two trials? Well, we've just seen that all the compound outcomes are equally likely. So, in the situation where outcomes are equally likely, we know how to calculate the probability of events. We just count up the number of successful outcomes and divide by the total number of outcomes. So the question here is, how many outcomes give us exactly one head? So for this event, there are two successful outcomes. Either we get heads and tails, or tails and heads. These are the only outcomes that have exactly one head. So two successful outcomes and 4 total outcomes. That means that the probability of the event is 2/4. And 2/4 is equal to a half. Let's look at some more examples of compound events. So let's say that we flip a coin and roll a die. we might ask, what's the probability of getting heads and 3? So what's the probability of the event of the coin showing heads and the die showing 3? So these two trials are independent. So we can apply our multiplication rule to calculate the probability of the compound outcome. So the probability of getting heads and 3 is equal to the probability of heads times the probability of 3. And now with a fair coin, the probability of heads is a half. And with a fair die, the probability of rolling a 3 is 1 over 6. So we see that the probability of the compound outcome is 1 over 12. One more example. So suppose that we wanted to estimate the probability that the winners of next year's football and hurling championships will be Kerry and Kilkenny. Well, one way to approach this would be to look at the last 10 years, and we see that in the last 10 years, as of 2011, 4 football championships have been won by Kerry and 7 hurling championships have been won by Kilkenny. So, let's see, the probability of Kerry and Kilkenny winning. Well, this is a compound outcome, and we would expect that the hurling and football championships are independent of each other. You might argue with that, but it's a reasonable assumption to say that the football and hurling championships operate independently. So to calculate the probability of this compound outcome, we can use the multiplication rule. Now, that means that the probability of Kerry and Kilkenny winning is the probability of Kerry winning times the probability of Kilkenny winning. And now we need to estimate these two probabilities here. But we've seen in previous lessons that one way to estimate probabilities is to look at relative frequency from past trials. So this is where our information about the last 10 years comes in. We see that in the last 10 years, Kerry have won 4 out of 10. So we'd estimate the probability of Kerry winning to be 4 out of 10. That's the relative frequency. And what about Kilkenny? Well, the relative frequency of Kilkenny winning in the last 10 years is 7 out of 10. So the answer that we're looking for, our estimate of the probability that Kerry and Kilkenny will both win, is equal to 28 over 100, or 0.28.